So I'm Richard Roberts. I'm a postdoctoral research fellow at the Computational Media Innovation Centre. I studied with Victoria University to finish a PhD in computer graphics. And over the last 2 years I've been working with Ken Anjo and the rest of the Future Studio Solutions team. On that team we go and talk with industry partners, both nationally and internationally, to identify key issues in production pipelines. So this process works by first surveying existing literature and finding a clear gap between where the cutting edge of research is and where the industry problem is. Based on that discussion, we bring back key research ideas to CMIC. Often this requires a different type of thinking when we deliver and incubate potential solutions. So one of the projects I've really loved being a part of here is MRSS. To introduce this project, I want to walk back to when we first travelled to Japan and talked with some of the market-leading companies there. We found that a key issue for them was being able to process photogrammetry assets. So the seminal moment for this project was thinking about how do we enable compression to preserve some of the fine-scale details that are hard to identify as being necessarily important to the shape. So we developed a type of importance analysis scheme that would scan over the 3D mesh and identify which parts appeared unique up close. So one of the technologies that they really needed was a better way to compress these assets while preserving the detail and the quality that comes out from that capture, providing a fast implementation which has already been tested for different production situations. A key concern for us when designing the solution that we put together, of course when we're looking at a really complex mesh, we need to produce a lot of that importance mapping automatically. We also need to allow the artist to define their own level of importance if necessary. We developed a mapping scheme that would work with standard content creation tools such as ZBrush, where the artist can go and modify their results to best fit the case that they have at hand. So a key concern for us was to make this whole experience comfortable for an artist, which meant that we couldn't take more than a few minutes to turn over one of these models. Being able to provide a tool like this that's suitable for artistic use means that it needs to run really fast. So one of the key pieces of work that we did was optimization around the way that the algorithm calculates these saliency maps. And so we developed an adaptive subsampling scheme that was able to cleverly use some but not all of the information at the mesh at different levels so that we could increase the calculation speed by up to 1,000 times for the types of meshes that you see in production. And so for the first time we were able to put this power of saliency mapping into the hands of artists working interactively with the tools. So now that we've got this far, we're excited to bring this into a commercial product that artists all over the world could interact with.